Okay, so I'm using Lucidchart. So my goal here is to help everyone understand how end-to-end data pipelining work, right? So imagine that you run a business or you work as a data engineer for a startup, and of course any kind of business will have the product they have. The product could be a mobile application, it can even be an e-commerce, right? Store, online store that's selling products, and they will have different kind of databases and data sources, right? So let's try to do a little bit brainstorming, right? Let's say we run a company that sells a company that sells a B2C company that sells some sort of product, right? B2C business, any kind of product they can sell, right, online. And they do all kinds of business activities, right? So they do, let's say, right, so the products, so they have some sort of product database, and of course, customer relationship management tool, right? CRM tool. So these are sales related, right? Because when you have a product, you're trying to sell it to the customers. But what drives the product sales? And you probably need marketing, right? And of course, you have the finance and accounting department, right? So the company may also have, let's say, it's an online platform, let's say. So you'll have platform or application related data, right? And then of course you have the customer engagement data. Okay. Okay. All right. So let's say the web application the company has, right? When you have a web application, right? Let's say the customers will come to your web application and they will interact with your product, and they do a free trial, and then they would like to sign up or subscribe to your to your service. They pay a monthly fee, or it could be a one-time purchase, right? Some sort of online product for $99 a month, or right. So where do you think this kind of data will be stored, right? What kind of, where is the data stored if you run a web application? Feel free to unmute yourself and speak up, or you can type your answers to Zoom chat. So the question was, if we have a web application, right? Where do you think the data is stored? In the cloud. Yeah, makes sense. The company is, let's say, is a startup, right? So they don't have legacy systems. So the data is most likely stored in the cloud, but the data is definitely stored in a database somewhere. But let's say that the database is running in the cloud, in AWS cloud. Makes sense. But they definitely have some sort of operational database, right? Okay, or application database. Okay, and it interacts. So your web application interacts with the operational database, right? Or the production database, basically. Okay, it keeps, stores all kinds of data that feeds into your web application. Okay, it could be the customer product usage, customer engagement, when the customer log in, when did the customer sign up for your service. So some of these data will definitely be stored in, right, the database. It could be a relational database, such as, let's say, PostgreSQL database, right? Okay, but it could be a NoSQL database as well. Okay, now, where do you think the customer relationship data is stored? I'm not sure if you guys have experience working, because some of you guys work, as data analysts or data scientists. I'm not sure if you have worked with CRM data. Do you know that, where the CRM data is typically stored? these are, the sales related data. Bingo. Yeah, Salesforce, or could be HubSpot, right? So let's say the user, right, started to use your web application, right? And then, of course, at the very beginning, right, before the user signs up, they're anonymous user. So, of course, we would like to encourage the user to purchase the product, but a lot of times, you don't really know much about these customers. So maybe you have an online form, right? And they subscribe to the newsletter, and they fill out some form, or maybe they directly create an account in your web application. But a lot of companies use a Salesforce, right, as some sort of sales tool. So let me see if I can find that. Let's say Salesforce, right? The company will use the Salesforce as a sales tool. So let's say the customer fills out a form, and the data actually is directly sent to Salesforce, right? So let's say this is the customer, okay? And then you also have the salesperson, right? So you have your sales team, okay? Right, the sales team will be basically looking at the Salesforce, and then they'll get notified if there are new customers, right, signing up for their service or download a form, right? And the sales team will basically be reaching out to the customer, right? And then start the customer relationship management. And the goal, of course, is to make the sales happen, right? To sell the product. Okay. So how do we get Salesforce data then? Can you take a guess? Or if you have experience, share with us. Yeah, Justin, that's a great point. API. So HubSpot, Salesforce, they all have APIs. So you can write, Python script, right, to collect data from, let's say Salesforce. Yeah, that's usually what the data engineers do. So data engineers, sometimes will need to write, the connectors, or, what Priyanka said, data loaders, but connecting to Salesforce API using some sort of credential, and you would like to download those CRM data into your company's data system, right? The sales team, they're not technical, right? So they just need to log into Salesforce, and they will be able to see the contacts, the leads, right? The potential customers, and they manage the customer relationship, sending them emails, giving them calls, and they're going to log all of those activities, right? And then the customers are basically going through a sales funnel, right? From a contact to lead to opportunity to eventually maybe, a deal, right? That's basically how sales funnel work. So most of the Salesforce tool, they have dashboarding capability already, right? The sales team will be able to log into Salesforce, and they will be able to look at those dashboard that's, pre-built by Salesforce tool. They'll be able to know the funnel, the sales, right? The sales manager and director can log in and see those info. But a lot of times that is not enough, right? Because the sales team is lacking the product engagement data, because after you make a sale, let's say you sell the product to the customer, right? And the Salesforce is only used by the sales team. So they know what the sales activities are, but they don't know the product usage, right? Because maybe this is a subscription business, right? And 3 months later, the customer stopped using or unsubscribed from the service, so they stop paying. And the sales rep, right, would like to, basically re-engage the customer, but they don't have too much information about this customer and the product usage at all, right? So that means they need to get that data from the product team or whatever, the web app team, right? Because the customer, product usage data is here. And in the Salesforce, we only have the sales data, right? So we basically need to combine, right, or merge the product usage data and your sales CRM data together, or somehow you need to upload the data back to Salesforce. So the sales team will know, well, this is a customer that purchased our product 3 months ago, but this customer only used the product once, right? And then never came back, right? Very low product usage. And then the sales will have more context when they reach out to the customer. Why is this product why is the customer not using it? But 3 months later, that's probably too late. You need to have some sort of trigger, right? 2 weeks in, the customer is not really actively using the product, then this customer is very likely to cancel the service. So you need to be more proactive. So you need to sort of feed this kind of information back to the sales system, right? The Salesforce system. So that already creates the need for us to integrate some of these data together, right? So ideally, if we identify the customer by email, so in Salesforce, right, the unique record is based on email. And then when a customer signs up for your service, maybe the customer is using the same email. You would like to merge the data based on user email, and then we can do all kinds of analysis. Okay, so Salesforce, how do we get Salesforce data? And of course, they have an API. They have an API service, right? And the data is typically stored in the Salesforce database, right? Very complicated database because they have multi-tenancy. So, company A's data and companies B's data, right? They might be stored in the same database, but they cannot talk to each other because you need to, protect the customer's data, right? So this is a separate topic, multi-tenancy and things like that. But let's say there's the Salesforce, right? The Salesforce, okay, database. Okay. And through the API, we can get data from the database, right? So that's the API. All right, I'll try to make it simple, okay? And then the company, of course, has many other sources, right? So data can come from, let's say MailChimp, okay? Right, MailChimp, let's assume that MailChimp is email marketing tool, right? You're sometimes the email, it's better to be sent by the sales team, right? But a lot of times you just want to do marketing communication to let people know about the new service, right? The new product. So marketing campaign emails will be sent to the customers, right? And that data is for, of course, MailChimp has a database as well, and then make it available through the API, right? And these are the SaaS platforms, basically. All right, so we have 3 data sources now. And sometimes data come from some sort of, APIs, okay? I'll just leave it here because the way we ingest data might be slightly different, okay? All right, so these are the applications, right? Data engineers don't get to control all of these because, these are either web applications built by company's developer or, data are coming from a SaaS platform, or you can do web scraping or collecting data directly from some sort of API. Okay. All right. Let me make this transparent. But these are basically application data. Okay. Now, this is the starting point of data engineer. data engineering, right? So we have data from many different sources. Now we would like to integrate these data. The first thing, so a typical data workflow is, ELT or ETL, right? Okay. So E is short for extraction. So how do we extract data from different sources, right? We'll start from, let's say the MailChimp API, okay? Of course, we can work with the API to ingest the data, right? So let's say the data engineer will be, let's say, writing some Python code, okay? Right, to interact with the API, to read the data, okay? And that means we have a Python script, right, to collect data from MailChimp API, and then let's say we're going to write the data out somewhere, right, to the data lake, for example. Right? So this is Python scripts, okay? And this is basically also called a connector, a data connector that you custom build, okay? But just keep in mind that whenever you're writing some sort of custom connector, the developer or data engineers will need to be maintaining this, right? An API may change and your pipeline may break. So just be prepared for that, okay? So we can always write custom connector, right? But there are also some other, right, software services such as Fivetran. Let's see if we can find logo. Right, so maybe we use Fivetran. Fivetran is a SaaS platform, right, that helps the company to ingest all kinds of data. And all you need to do is just doing a bunch of configuration. Okay, it's a low-code environment. So the connector is basically maintained by Fivetran, by that company, and your data engineer don't need to write custom code anymore. And it's just a bunch of configuration, and it's pretty straightforward to use. Right? And of course, it's not free. So Fivetran will charge you based on how much data you ingest, right? So the cost is not low. If you have massive amounts of data, and using Fivetran can be quite expensive. Okay, but for a startup, I think it makes a lot of sense because the cost of hiring a dedicated data engineer to write custom connectors, and let's say you have 10 different connectors, you probably need a full-time data engineer to do that, right? And that cost is pretty high. And maybe working with Fivetran, you're gonna pay 50 grand or 100 grand every year just to ingest data. However, it's much easier to maintain, and it's a lot faster to build, because just within a matter of hours, you'll have everything configured, and it will start ingesting data. But if we need data engineers to write custom code, it may take a significant longer time. It might take weeks, right? And you also need to maintain that. So for a lot of the small business, it actually makes sense to work with tools like Fivetran. But just so you know, it's basically just a data connector, and it builds the infrastructure for you to actually ingest data, and you can choose any kind of data destination, whether the destination is a database, a data warehouse, or it could be a data stored in the cloud as well. But that will save you a significant amount of time. And Fivetran is mainly collecting data from SaaS tools, right? Because there's so many connectors that you build. And how do you tell, what is a good data connector tool? Well, the number of connectors they have, right? The number of services they support is definitely one of the main reasons, right, why companies will choose Fivetran. But there are also open source projects out there, such as Airbyte, which is pretty decent, and it's getting more and more popular. But working with open source means that you probably need to maintain your own infrastructure to do data ingestion, right? But they have cloud-based services as well, so that you can subscribe to. Okay. But sometimes what if you have some sort of unpopular API, right, that you're working with, and it's the connector is not available, it's not provided by Fivetran, and then you will probably still need to write your own, connector, right? But in this case, you might be running the Python script, okay? Maybe using Amazon Lambda service, right? So this is serverless, because if you're just collecting data from one data source, do you really need a server running 24/7 to do that? It's probably, an overkill, right? So maybe we can set up a scheduler, right, running on Amazon, Lambda service and API gateway, and it just reads data from the API, whatever, data API, once a day, for example, or a couple of times a day, right? And Lambda service will be a lot cheaper. And of course, it has its downside, but it works most of the time, okay? So that's another way to ingest your data. And of course, you need to decide where to send the data, right? But we're talking about the data, ingestion and connectors. But majority of your data will still come from your application, right? Imagine you have millions of customers already. The customers using your application generates a lot of data, right? And that data can be stored in PostgreSQL or MongoDB, whatever database you use. How do we ingest data from a database into some sort of destination, such as a data warehouse, right? Any idea? Or do you have any experience with this? Like, how do we sync data from a database, let's say, to a data warehouse or a data lake? There are actually many different solutions. Can you think of any? Yeah, we can build some sort of pipeline to read data, right, from a relational database. Like, I guess the most rudimentary way of doing this is just like, we run a Python script. The Python script connects to, the PostgreSQL database, right? And it just run a query to say select star or select asterisk and select all the data from that table, and then we save it somewhere else, right? The downside of this, of course, is, do you read the entire table? Let's say you have 10 tables, right? And pretty big table in your source database, and it has millions and millions of rows. And every day, there are tens of thousands of new records that got inserted into the table. But you already have like 10 million records, right? And the table just keeps growing. Do you always read the entire table on a daily basis and move that to another destination? That's probably not very efficient, right? Because you're copying a lot of data like repeatedly, basically, right? You probably just need that incremental change, right? So you can do some sort of incremental, loading. So there are different strategies. Well, you can use AWS Glue. And AWS has, database migration, service as well. Not the best use case here, but the most popular approach is something called, CDC, right? So we set up change data capture. It could be an agent running locally directly on your database. And whenever there are changes, it pushes the data to somewhere else, right? Or some sort of CDC service, right? That constantly polls the database to detect changes, right? And it's only sending the changes, okay, to the downstream service or whatever data store. Okay, so CDC is an important data engineering concept because a lot of companies, their databases are basically massive. You're definitely not going to copy the entire database and dump that into a data lake on a daily basis. It's always, about incremental change, right? All right, so that's the data connector part, right? Just figuring out where the source data is, source data is, right, making a connection and download the data somewhere, right? But where do we store the data? That's the next question, right? So we have data collected from some sort of API through Fivetran, you know, from SaaS platforms and from your own company's, you know, production databases, right? So there are two different schools of thought right now. And of course, we can store all of your data into, right, in the cloud, let's say Amazon or AWS S3, okay? S3 is simple storage. That's an object storage, right, service. A lot of companies, if they use AWS, that's the backend data store for their data lake, basically. So data lake is one approach. So you can save the data to data lake, right? Fivetran is a little bit special. We'll talk about that. But that's one place where you can dump all of your data, and then data integration happens from there. Okay, and data lake became popular, you know, during the big data era, right? Because the company has so much data, storing all of those data in a relational database. Sometimes, you know, it doesn't make economic sense. And the company has a lot of unstructured data as well. You know, if you have a chat application, you have a lot of natural, you know, text data that you want to apply, you know, natural language processing to later. Better to keep those data in the data lake, like storing them in Amazon S3 or some sort of NoSQL document database. Okay, so this is where the data can go, but there's also the modern data stack where people believe in data warehouse. Right, so data warehouse. Okay, let me see if I can find Snowflake logo. There we go. Okay, let's say we're running Snowflake as a data warehouse. Okay, so in the ETL world, right, data tend to be ingested into the data lake first, and then there will be data transformation service, right? So this is where ETL or the transformation, okay, or I'll just say ETL happens here, right? Reading data from your data lake and running the transformation service or whatever data pipelines, right? So ETL pipelines, and companies might be using tools such as, you know, Apache Spark. In AWS, they might be using Glue. Some people might be using Databricks, but you can use even just using Python and Pandas if your data is not very big, right? And you can use serverless tools such as Athena, TrinoDB, right? There are a lot of different kind of tools you can use. Okay, but that's the ETL pipeline, right? Just this is where a lot of data cleaning happens, right? And then a lot of data merging joins, right? Because, you know, finally we have the CRM data, customer data, engagement data, product usage data, all in the same place, right? In the data lake. And as long as we can identify these, you know, through some sort of unique ID, such as the customer ID or email address, and then you can merge these data together, right? And then you can, you know, relate your sales data to product usage. If someone cancels the service, is it because of the product usage, or maybe something's wrong on the product service side, right? And this is the very traditional approach, right? It's been around for many years. Okay, and a lot of big data processing happen here in the data lake. Okay, and we'll talk about the lakehouse stuff later. All right, and but there are new schools of thought, right? People believe in ELT, which means, well, why don't we just load all the data into a warehouse first? Because maybe warehouse is the final destination. Because, you know, traditionally how people do that is we're going to dump all of our big data into the data lake, and then through ETL pipeline, we're going to clean the data, do all kinds of, you know, data flattening, denormalization, and then we're going to send them to data warehouse. It can be Snowflake as well, right? The data warehouse engine doesn't matter, okay? And then in the data lake, right, people might be using, Hadoop and Spark. Okay. So this is the ETL approach. However, the analytics on the analytics engineering side, or what people call the modern data stack. It sounds fancy, modern data stack. It typically involves tools such as, Snowflake, Fivetran for data ingestion, right? And also DBT for orchestration, or, automation, right? So DBT is a data transformation tool, okay? So that means Fivetran can actually ingest the data directly into the data warehouse, and there might be a staging area, right? So I'm not going to dive into detail, but all of your data can be staged directly inside the warehouse, right? A staging environment. And then transformation happens, right, inside the warehouse. Okay. Okay. Look into DBT if you haven't heard about it, but it's a pretty cool tool. Oh, what happened? Okay. DBT runs it on its own server, right? It doesn't really run directly inside the data warehouse, but when it runs the DBT models, all those queries are actually executed in SQL, right? So it works with the modern data warehouse tool, okay? And it's mainly used for workflow transformation and automation. It does testing as well. But the data can come from, Fivetran, right? And of course, you can ingest data directly into your warehouse. It doesn't have, we don't have to rely on Fivetran, but it's one of the popular selection, option, right? But there's open source version such as Airbyte as well. Okay, so transformation happens, okay, inside the warehouse. Okay, so if you want to work as an analytics engineer, I think some of the tool stack you need to be very familiar with are Snowflake, right? But Snowflake is, using Snowflake is straightforward. You just write SQL if the data is already prepared. But working as a data engineer and sometimes as a data architect, I think you need to know data modeling very well, because we need to understand how to store data and structure data in the data warehouse, right? So you need to do some sort of dimensional modeling or some sort of data modeling. It doesn't have to be, the Kimball approach, right? Because in the DBT or the modern data stack world, people believe in a very flattened data structure, right? They call that white tables. So that, allows you to avoid a lot of the joins. And a join basically happens in the DBT pipeline. And DBT is sort of the enabler of that, right? So that significantly simplifies your ETL and ELT workflow, which is pretty cool, right? But you still need to know data modeling and how to store and structure data, and working with, the DBT workflow. So that's analytics engineering. It's really great for someone who's coming from a strong SQL background and you would like to work as a data engineer. And that's basically analytics engineering. And most of your activity actually happen inside Snowflake or any kind of data warehousing tool engines, such as Redshift, Google, BigQuery, Microsoft Azure Synapse, right? But another type of data engineer, they work with open source tools, the big data tools such as Apache Spark, right? So these are the companies that have invested in Hadoop Spark or maybe Databricks, right? So they still use a lot of SQL because, the end destination might still be a data warehouse. For example, Uber has a data warehouse, but their data is so massive, they can't really go with the ELT approach, because the ELT approach means that you're going to dump all of your raw data into the staging area in the data warehouse. But we're talking about petabyte scale data, right? That's like millions of gigabyte on a daily basis. So it's going to be super expensive if you're going to use a warehouse for that. So they are going to dump the data into the data lake, right? Because storage, big data storage in the lake is much cheaper, right? And then we can use, big data tools like Apache Spark, right? Apache Beam, and TrinoDB, for example, to do the data transformation. And that usually requires a distributed cluster. That's why we need Apache Spark, AWS Glue, or Databricks to do this kind of transformation. Spark is written, in Scala, right? It's a JVM-based platform, but we can use the PySpark, Python API. You can use Scala, right, to do the transformation. And PySpark is actually becoming more popular. A lot of companies still use Scala and Java, right? For example, at Twitter, they mainly use Scala. They don't for data engineering, right? A lot of software engineering as well. Okay, so this is the data lake approach. So there are a lot of data engineers will, work with this kind of tech stack for data engineering. Okay, so sometimes when you read job descriptions, you might find it very confusing, right? Because the company will ask for everything. I think the first thing you can figure out, during the interview is just try to figure out their data stack and what do they believe in? Because there are companies that do both, but you probably don't need both of these. If your company believe in the modern data stack and everything is SQL based, right? That's quite common actually, right? But SQL is not going to solve all the problems. So they will still need some other tools for sure, right? But there are also companies that, just built everything on top of, Spark, Data Lake, right? Or the traditional ETL pipelines. The downside here is that, it's relatively slow, right? Because we always need to engineer things ahead of time, build the pipelines, figure out how to do the data transformation before the data land in data warehouse for analytics, right? And what makes Snowflake or the ELT approach popular is that the data will be ingested into the staging zone in a warehouse directly. So the data is available immediately and they can start doing analytics. So the speed might be a lot faster. However, it really depends on how massive or how big the data is, right? If your data is really massive, it probably doesn't make sense for companies to use this approach because the cost might be really high. Storing data in the data lake, right, will still be much cheaper, right? And then you can run your ETL pipeline. So it depends on the company and their needs, right? However, I think we missed something. What if the company wants to do real-time analytics, right? Now, this is where Lakehouse comes in, right? Because we know Spark has the Spark streaming capability, right? Streaming analytics, or whatever streaming data processing using Spark streaming, right? Apache Beam, okay? And Flink as well, right? These are some of the streaming tool. Okay, so that means we need real-time data ingestion because whenever you are dealing with the streaming data, the data can need to be ingested in real time, right? So let's add a real-time data ingestion tool here, right? Kafka or Kinesis, right? It's a distributed messaging queue, right? That's really good, very popular for data streaming, which means Data coming from, let's say, change data capture, right? Data can actually be sent to Kafka, queues up your data, and store the data on disk for many, many days. So your chance of losing data is very low. And your Lambda service can collect data and dump that into Kafka, right? Fivetran. So all the data that's generated in real time or on a regular basis, you can dump them into Kafka, and Kafka can still relay the data, right, through Kafka Connect and send that to Amazon S3 or into your Hadoop data lake. But at the same time, the data can be available for analytics right away, right? So we need Spark streaming, connect to Kafka, and then you can do the real-time data aggregation, right? And then you can send the data somewhere. We'll talk about that. You can send the data to a real-time dashboarding tool, to some sort of database endpoint, like destination, right? Okay. All right. But recently, there's also a new kind of concept that's getting popular, which is the new data format. Okay, Iceberg, Delta, right? And these are just table format, right? How the data gets stored. It's not necessarily a processing engine, right? But Apache Iceberg, Delta, these are the table format, which means data can be, written into a table format and it has ACID attributes. Okay. It solves one of the challenges of data lake. So it's built on top of data lake, and it's called Lakehouse. Right? Because the traditional data lake technology is not really transactional by nature, right? So we always write data to some sort of object store, right? Some distributed file system, but those are batch file. And the data processing speed will be very slow, and it's very hard to delete data, right? Because when we work with Hadoop, you either create a new data set, right? Even if you want to, let's say you have a table that has 1 billion records, and you just want to delete one record, right? It's actually not that straightforward. If we have the 1 billion records in a database, we can easily delete one record, and data might be indexed as well. In Hadoop, you don't really index data, right, in S3. And deleting one record pretty much means that you need to create a new data set by removing just one record. So you're like reading 1 billion records, remove one of the record, and then you save the data again, right? So the performance is not going to be very good. It doesn't support a lot of real-time application, right? So Lakehouse sort of adds a couple of more layers of metadata information, and that allows you to easily do data insert and delete efficiently, right? And it works really well with Spark streaming as well. So that's the Lakehouse stuff, right? So these are some of the new trends, I guess, in data engineering. Data lake that has been around for many years, ETL, right? And now Lakehouse. There's also the modern data stack, ELT, ingesting data directly into the data warehouse. Okay. However, up till this point, data engineers' job is not done yet, right? They'll be doing all kinds of data modeling, structure the data and tables, do integration, data transformation, data cleaning, and eventually they want to load the data somewhere, right? So in the traditional ETL approach, right, data might actually be loaded back to a data warehouse, but the data can go somewhere else as well. It doesn't have to go, to the data warehouse. It can go to some sort of SaaS software as well, right? So there's a new concept recently called reverse ETL. right? It basically means that sending data back to where they come from, right? So your data warehouse data, right? Or, might be sent through reverse ETL. We would like to send or push the data, the enriched data. We would like to push them back to Salesforce, for example. Okay. Right. And we may want to push them back to a MailChimp as well. And that's called reverse ETL. Now, the data we're pushing back to MailChimp and Salesforce, they have been enriched. So we not only know that the customer has been sent 5 emails, we also can aggregate those data and tell that, well, this customer received 5 marketing emails, open 3 of them, right? And clicked on a couple of links and buttons on one of those emails. And we would like to aggregate those data, and along with the product usage and customer segmentation, all of those insights, including a machine learning model prediction. And we would like to push that back to the SaaS tools, right? Salesforce, MailChimp, Google Ads, and Google Analytics. So a lot of data you can push back to many different types of SaaS platforms, and that's called a reverse ETL. And there's some, open source tools in the reverse ETL space. And High Touch is one of them. It's, even though it's not open source, but it's pretty popular, right? So High Touch. There's also Census, right? These are some of the popular ones. Okay. And that's what data engineers will do as well, to do the reverse ETL. But if your company work on, let's say, the Azure cloud, then you might as well just leverage the Azure Data Factory before reverse ETL tools exist. Right? Company will still want to push the data back, so they either build their own connectors and work with those APIs to push the data back themselves, or they leverage some sort of Microsoft tools, ETL tool, right? But recently, the reverse ETL concept became kind of popular. And it sort of evolves around the data warehouse concept. So reverse ETL works really well with Snowflake and all the ELT stuff. Okay, so well, that's what I would like to demo to mainly demo today. Hopefully that helps you understand how, gives you an example of end-to-end data pipeline or data flow, right? And there are many different options for the company to choose when they build their data stack. Some companies has all of these. Some company may focus on data lake, and there are definitely a lot of startups that purely just focus on the ELT approach, right? So they go with Snowflake, dbt, which is very convenient. But when their data stack become more sophisticated, they will definitely need to involve things like Apache Spark and some other tools. All right, cool. Do you have any questions? If you don't have any questions, let's move on. So I have a couple of more slides just to introduce, how to become a data engineer. So first of all, I think you need to follow a very structured learning path. So I'm showing you WeCloudData's data engineering bootcamp curriculum, but based on this, you can take a screenshot. You can follow this to self-learn as well, right? So here are what we think someone will need to learn in order to become a modern data engineer. You don't need to know all of these in order to, right, to work on, on a data engineer job. But just to prepare for the job market, because sometimes you never know, ideally, both at analytics engineering, modern data stack, and big data, right? Because otherwise, if you only know SQL and analytics engineering, then you can only find, the analytics engineering job. Then the Spark, big data, lakehouse jobs might be a little bit challenging for you to get, right? So that's why, from a learning perspective, we recommend the students to learn as much as possible. But of course, learning too many tools sometimes can be very overwhelming and confusing. So working on some sort of end-to-end data project will be very helpful, right? From a programming perspective, we would recommend getting familiar with Linux, right, operating system, the basic command line tools, and then you need to be very strong in SQL if you want to work as a data engineer, and know at least one of these programming languages. Choose either Python or Scala. In our program, we used to cover Scala, but ever since we added analytics engineering, data warehouse, and some of the new stuff, we felt like, there's just not enough time for us to cover everything in 6 months. This is a part-time program. So we made Scala optional, and but we still have all the recordings the student can go through. The instructor will cover a little bit of Scala when we touch, Apache Spark, but we mainly focus on PySpark. Data engineers will need to know a little bit cloud computing and infrastructure, right? So you need to know at least how to work with, just pick one of these, AWS, Google Cloud, or Azure. If you pick AWS, that's what we choose to focus on. Then you need to know data storage, right? S3, how to launch instances, or virtual service or containers, right? EC2, Lambda, which is serverless. A lot of data engineers actually write serverless functions to do either data ingestion or build some sort of simple APIs. EMR is the Databricks in the AWS cloud, right? So that's the Hadoop and Spark cluster. So you can use EMR, but you can work with the serverless version, AWS Glue as well. And Athena is based on Trino, or previously it's called Presto, open source by Facebook. Okay, it's a serverless SQL engine, pretty powerful. And then we move on to teach, data warehousing. So we focus on Snowflake, and since we introduced Amazon Web Services, we'll touch on Redshift as well. I don't think you need to learn, 5 different data warehouse engines. Focus on one of them, and because the primary tool is still SQL, but I think understanding the database internals and how data modeling in the modern, or the Kimball, data modeling approach, for example, is important, right? And understand the difference between dimension modeling and how to build wide tables, right? Which is the modern data stack philosophy. And then moving, you need to move on to big data. I think understanding MapReduce, right, how distributed system work is important, but the focus can be, on Apache Spark side. Hadoop is still used in many companies, but it sort of, became a legacy system. But understanding the concept of MapReduce is still very helpful, because that's how Spark works as well. Right. So, and then a big focus is is placed on Apache Spark, on Databricks, and also we cover how to work with Glue, and you build Glue pipelines, which is serverless. On the big data side, I think data engineers will need to know at least one of those NoSQL tool, right, or NoSQL database, whether it's Elasticsearch, which is a search engine DB, or DynamoDB in AWS. It's a key value store, or you can pick Cassandra. Just get familiar with at least one of them, and try to understand why NoSQL is more widely adopted, right, in some of the web scale applications compared to the relational database. So at least you need to understand the difference, the CAP theorem, right? So that's the big data part, and then after learning all of these tools, I think the concept of ETL and ELT is very important, because you can achieve ELT and ETL using many different tools, right? So learn how to do data ingestion, right? Setting up Airbyte or Apache NiFi for data ingestion, data integration using Spark in Spark SQL or PySpark data frame, and also learn how to do streaming data processing using Apache Beam or Spark Streaming. And after that, after big data and ELT, then we'll be covering data lakehouse, right? So we'll touch on Apache Kafka, lakehouse architecture, Apache Hudi, and Databricks or Spark Data Lake, a Delta Lake. And then all of these workflows, right? We want to automate them end to end. So when some part, right, fail, we may want to retry, or we may want to set up like some sort of Slack notification, email notification. And if this fail, maybe the ETL pipeline will not trigger because that's one of the most important data sources, right? So we set up some sort of dependency, right, between each small workflow. So each component in your data pipeline, right, and the upstream steps need to succeed before we kick off the next step, right? So and we can achieve this using tools such as AWS Lambda step function, if you want to do this in a serverless way. But another industry tool that people use is called Apache Airflow. It's an open source tool, but there's also alternatives such as Daxter and Prefect that are also very popular nowadays. And of course, DBT, if you want to work with ELT and Snowflake. So these are the two orchestration tools that we cover in the program. And also the CI/CD part, right? Version control, containerization, the basics of DevOps, right? How to do unit testing of your transformation functions, how to do continuous integration on your data pipelines and Airflow pipelines, and how to structure your data engineers folder, right? And also in the end, we cover some data governance, so data quality, metadata management, data cataloging tool, Amundsen, which is also pretty popular. Data cataloging is pretty hot topic that I think every data engineer need to know. And because we have both full-time and part-time options, students in the full-time program also get to work on real industry projects to build up their work experience. So we cover project management as well to help the students who don't come from a tech background to get familiar with Jira and the general agile project management workflow. And one of the most important thing, right, of learning data engineering is just to get hands-on. You don't expect to become an expert by just reading tutorials and just watching some online courses. You need to get your hands dirty, and just try to follow some sort of template project and expand on it, right? And you need to have your original idea. So I think to become a data engineer or learning data engineer, you sort of need to push yourself to become a data architect. You need to architect some sort of data pipelines, right? You need to decide. There are a lot of decisions you need to make along the way. So which cloud do we pick, right? Where do we store data? Is it S3 or is it a database or data warehouse? How do we ingest data? Because every decision you make, there are probably 5 options you can choose. So everyone's pipeline will be different, and the tools they choose will be different. And during interviews, you just need to convince or explain to the hiring manager why you make some decisions. It doesn't always need to be the perfect solution, right? Because 2 different companies using the same tool, they may end up doing something, their data engineering pipeline, very differently, depending on the data science, the latency requirement, and the business policies and rules. I think that's the fun part of data engineering. You can't really just apply, a very generic, of course, there's some patterns you can follow, but, there's no single rule of thumb, I think, in data engineering. We can always try different approaches. And the tech stack may also, change quite often. Like every 3 to 5 years, the companies will probably change their tech stack on data engineering as they become more sophisticated. Okay. All right. So again, I think because there's so many tools one need to learn, I think a lot of the beginners will make a mistake. Right? They tend to take a lot of online courses, learn many different tools, but they never put them together. Right. So it's important to after learn all of these tools, just make them work together and build a data pipeline, right? You learn 20 tools, but maybe pick 7 or 8 of them and build a data pipeline. And I think the project will definitely impress the employer. Okay. And it gives you more talking points during interviews, of course. And don't forget about the business, right? And recently we worked on a pretty big data warehousing project using Azure Synapse. And we noticed that we actually didn't end up spending that much time writing code, but we end up spending so much time working with the business, right? Just trying to figure out what they want, where the data come from, and decide how we want to structure the data. And when you build a data warehouse, you need to do data modeling. But without understanding how the business is going to use the data warehouse, and you can't just build your data model, like you can't, right? So it always needs to be driven by the business, and that's very important. And again, understand data modeling, and need to know coding for sure, Python, SQL, Apache Spark, understand how to, and automate workflow using Airflow and maybe dbt, SQL workflows, and also know a little bit infrastructure and tools.